Hello students, how are you? Hope you are all fine. Here I am Uma with another topic from Structure of Atom, the Rutherford's model of atom. Rutherford was interested in knowing the distribution of electron within the atom around the nucleus. So he conducted an experiment on a gold foil whose thickness was about 1000 atoms thick. He used alpha particles for his experiments. Alpha particles are doubly charged helium atoms. As we all know, helium, the atomic number of helium is 2. And now if we remove these 2 electrons from the helium atom, means helium atom minus 2 electrons, it will give you helium 2 positive. This particle is known as alpha particle, right? Now, according to the structure that was proposed by Thomson's, according to that structure, he expected a result that most of the alpha particles will be deflected from their path, right? Now, let us see the experimental setup made by Rutherford. He has projected fast moving alpha particles on the gold foil, and that foil is about the thickness was about 1000 atoms thick, and he recorded his observations. Depending upon the observation that he has made, he proposed a structure of atom. These are the nucleus. The black dots at the center of the atom are the nucleus, and he has placed a X-ray screen around this gold foil. According to Thomson's model of atom, this outer layer is positively charged and electrons are embedded in it. So, if that structure of atom was correct, so then the observations should be like that ki most of the alpha particles should be deflected and very few should cross this straight, will go straight. But the observations were totally different. Okay. Now, when he projected these rays on these particles, then he observed maximum number of particles, they go straight through the atoms of the gold foil. He obtained bright spots, maximum number of bright spots on this X-ray screen placed just behind the gold foil, which shows that these are the bright spots that he got on the X-ray screen. This showed that the atom, the most of the alpha particles, they move undeviated, they didn't get deflected. Very few of the alpha particles, they got deflected through the small angles. Why? Because alpha particles are also positively charged and the nucleus of the atom is also positively charged. So then the positive and positive charge, like charges, will repel each other. By this thing, he observed that very few of these alpha particles, they got deflected through very small angles, and very few, 1 out of 12,000, they traced back their path by 180 degrees. Means on the path on which they are coming, they moved back on that path. From here, from the observations of these experiment, he had made three major observations from that. First, that that alpha particles, major alpha particles, they go straight. Second observation, very few got deflected from very small angles. And the third, 1 out of 12,000 will be deflected on their path. They traced back their path. The further observations, that what were the observations that he has made? Most of the alpha particles, they passed straight through the gold foil. Some alpha particles were deflected by the gold foil by small angles. Surprisingly, out of every 12,000 particles, one appeared to rebound. What was the inference that he has made? That most of the space in the atom was empty. as most of the alpha particle passed without deflection. Most of the alpha particles they passed from the atom without deflection means maximum space of this is empty. After that, the second observation was that very few get deflected by the smaller angles, right? Because of this positive charge will deflect, will they deflect the positive charge again. Positive charge will repel the positive charge. Alpha particles are also positively charged, and this nucleus is also positively charged. Hence, because of repulsion, these alpha particles, a very few number of alpha particles, they got deflected from their path. And only a very small fraction, one out of every 12,000 particles, it rebounds, means whole of the mass of the atom and the charge, the mass and charge of the atom is concentrated here at the center of the atom, right? Now, Rutherford, based upon his observation, the structure of atom that Rutherford proposed was there is a positively charged center in an atom called its nucleus where all the positive charge and mass is concentrated. Next, electrons revolve around the nucleus in the circular path. As his experiment explained, that very few alpha particles got deflected and most of them passed straight, means these electrons will revolve around the nucleus in the circular path. The size of the nucleus is very small. Why? Because only one of 12,000 particles got deflected. Now, and the size of the nucleus is very small as compared to the size of the atom, right? Next, now the drawbacks. Now, why we'll be studying about the drawbacks of Rutherford's model now. As we have already studied that he has proposed a structure in which he said that all the mass and the positive charge of the atom is concentrated at the center of the atom, and electrons revolve around the nucleus in the circular paths, right? For example, this is an atom structure of an random atom, right? Now, he was not able to explain the stability. What does we mean by that? Students, he has proposed that the electrons are revolving around this nucleus in a circular path. And if the object is revolving, then it will lose energy. Means here electron will lose energy, right? And if electron will lose energy, then this positively charged nucleus will attract the electron towards itself with the more power. This will result in the decrease in the orbital radius of the electron with each successive revolution around the nucleus. Means with the release of energy, as the energy of these electrons decreases, then this positively charged nucleus will attract these electrons more effectively towards itself, and hence the orbital radius, the radius with which they are moving around the nucleus, will decrease and it will be falling towards the nucleus. After some time, what will happen? It will collide with the nucleus, it will merge in the nucleus, and hence this shows that the atom is not stable. But this is a contradiction because atom is a quite stable entity, right? For that, the other model of atom needs to be proposed, that is put forth by Bohr later on, and he was able to explain the stability of the atom in his model of atom, right? So this was a major drawback of the Rutherford's model of atom, that he was not able to explain the stability of this atom. This is all with our this topic. Hopefully the doubts that you have will be cleared by this video. Thank you. Have a nice day. If you like this video, kindly share, subscribe to my channel.